In atmospheric sciences, the pressure gradient is a physical quantity that describes which direction and at what rate the pressure changes the most rapidly around a particular location. The pressure gradient is a dimensional quantity expressed in units of pressure per unit length, or Pascal per meter. Mathematically, it is obtained by applying the del operator to a pressure function of position. Physical interpretation. Strictly speaking, the concept of pressure gradient is a local characterization of the air. The pressure gradient is defined only at those spatial scales at which pressure itself is defined. Within planetary atmospheres, the pressure gradient is a vector pointing roughly downwards because the pressure changes most rapidly vertically, increasing downwards. The value of the strength of the pressure gradient in the troposphere is typically of the order 9 pascals per meter. The pressure gradient often has a small but critical horizontal component, which is largely responsible for the wind circulation. The horizontal pressure gradient is a two-dimensional vector resulting from the projection of the pressure gradient onto a local horizontal plane. Near the Earth's surface, this horizontal pressure gradient force is directed from higher toward lower pressure. Its particular orientation at any one time and place depends strongly on the weather situation. At mid-latitudes, the typical horizontal pressure gradient may take on values of the order of 10⁻² pascals per meter, although rather higher values occur within meteorological fronts. Weather and climate relevance. Differences in air pressure between different locations are critical in weather forecasting and climate. As indicated above, the pressure gradient constitutes one of the main forces acting on the air to make it move as wind. Note that the pressure gradient force points from high towards low pressure zones. It is thus oriented in the opposite direction from the pressure gradient itself. Sound waves and shock waves are events that can induce very large pressure gradients, but these are often transitory disturbances.